Okay, what a day. Um, I hope you are all rested. Nothing like listening to someone talking 25 minutes about data to wake you up. So, what the hell is GraphQL and why should I care? As many of these talks today, this one is opinionated as well. And the title is basically how I felt when I first heard about GraphQL. I wanted to figure out what it was, so the title is what it is. So, a little bit about me. My name is Fatos Hoti. I'm originally from a small town in Croatia called Pula. You might know it as Pola. I'm currently working in Berlin for a company called Auto1. And we are dealing with used cars, so buying and selling used cars on a big level, on a big scale. And maybe you know, in Italy our brand is Noi Compriamo Auto. One more thing, we are hiring. I don't have a t-shirt, but like living in Berlin is not so bad, so maybe that's an incentive. Okay, what the hell is GraphQL? So how many people here knows what it is? Okay, so first thing that I thought it was a query language for graph databases, and as it turns out, it's not. It's not a database, it's not a persistence layer, it's not a DB, it's not a library, it's a spec. It's a protocol for clients and data sources to communicate. You can imagine it as a layer in between your data source and your client. So it's a middle layer between your client-facing application and your original data source or your source of truth. As you will see in this talk, it's strongly typed, which is a great advantage if you are using modern ways of writing JavaScript with TypeScript or flow type. The biggest problem was that you couldn't type API or remote calls. This fits perfectly into that development flow. So that was a missing piece of the puzzle when you were typing your JavaScript, and this technology takes care of that. So it's a query language for clients. So I started as a backend developer, as a PHP developer, and I always had the database in my reach. So I was the one defining the payload that I will send. The thing with RESTful APIs is that you don't always have the option of choosing what data you will fetch as a client. You're more or less stuck with the payload that the backend gives you. Here, GraphQL as a spec and as a query language allows for you as a client to define what your payload would look like. And one more thing that is really powerful is the ability to fetch multiple resources in one get-go. So just imagine that you have a properly created RESTful API, and that like all your resources are basically URLs. And if you can fetch multiple resources in one round trip from client to the server, it would be a benefit for you for sure. We'll show that later. Okay, so as I said, we are dealing with cars. We have a lot of clients attacking our RESTful API. And this is more or less a situation that everybody finds themselves sooner or later. So we have a couple of clients going on the RESTful API, and when we have to fetch nested or connected or even other sorts of resources, we tend to create multiple requests to the API. This is not a good solution, and it introduces a lot of bad practices. It introduces a lot of requests, a lot of latency, and altogether a bad user experience afterwards. So, you might be thinking about, okay, but there's a solution for that. We'll introduce an aggregation layer between our clients and our API. And this is a valid solution, to be honest. A lot of people have been doing it. To be honest, at the current company, this is our stack. This is how we do it. But we have, as I said, a lot of clients, a lot of aggregation layers, and the code reusability between aggregation layers is almost zero. People don't know what the other teams have been doing, and they don't have a centralized place where you can aggregate all the data coming from the API. So a proposed solution is very similar to one that we have now. We're just going to replace the aggregation layer with a GraphQL server. And how are we going to do it? We're going to use Haskell. No, I'm joking. We're going to use JavaScript. Okay. So the implementation we will use is, as a backend server, we're going to use Express, and thank God for Express middlewares, because a GraphQL server in Express is implemented as a middleware. So basically what you do is you use this Express GraphQL package, you install it, and you use it as a middleware. That will de facto take care of every GraphQL query that comes to your server. It all starts with a schema. Schema is a word that I don't like usually, but I'm going to use it now. It's a monolith. So it's a place where you define all your data mappings. And as data flows in two directions, you are obligated, if you want to have it flowing in both directions, you're obligated to create a query type and a mutation type. So query type is a schema, or a part of a schema, on which you define your data that will be queried or fetched. So basically a get. For everything else, like deletes, puts, patches, posts, we're going to define a mutation type on our schema. This is where you define how you will mutate your data on your API. So queries. There are different types how we can resolve a resource in GraphQL. And I think that the most important one is that we can resolve it as a promise. So if you're defining a query, you can easily say, as you can see here in this part, in this part with cars, you can easily see that we are defining our resources cars as a type list of car types, which I will show later what it is, and that it resolves as some kind of promise. So basically, in behind this code loaders cars load is a fetch. So basically, it's a promise that is executed and returns and resolved as a value. Also, we can define arguments on our queries. So, for example, if we need a car that we're going to fetch by a certain hash or by a certain ID, we can define this args node on our GraphQL schema and also type it. So we can say that it's non-null and that it's a string, which is also very useful. And we can also say that that type is a car type and that it resolves, again, as a promise. Also, I will show here, these loaders I will show here are basically cached requests that we can use to optimize our application to work faster. But what you can do, if you don't want to do that, is basically just resolve your promise as an API call and just return after then, return the response that you get from the API. Mutations have basically the same look and feel as any GraphQL query. The only difference is that you define arguments as things that you will send in your request. So if you want to define a mutation, something that changes your data, you have to define how that data looks. And in the core of everything in GraphQL is a strong type system. So all your data here will be strongly typed and more or less validated with this. As a resolving function, you will again call some API call, and as a return type is the one that you define as a type. So here I defined the booking type, which I will show you later, but that's the return type that our client expects after dispatching a mutation to the GraphQL server. So how does an object or a model or a resource, call it as you wish, look like? So basically here, it's a GraphQL object. We name it, we add a description, which is great because we are auto-documenting our data. And later on in graphical, I will show you how you can see what your data looks like, what it is, how it's described, and how it's typed. There are a couple of ways we can resolve fields in a model. There are simple types, like the one we can see with manufacturer, which is a simple mapping one-to-one where you have to change something. You can have a nested API call, So here we have equipment, which is basically our air conditionings, CD players, electric windows, and everything like that. And this is an API call that is being dispatched after the car object has been resolved. So we can have nested API calls for fetching nested resources on a resource. And the last is that I wanted to show is price. So it's a way that you can format your responses to what your clients are expecting. So we are currently in 12 or 13 markets, I think, that all have different locales, different formatting for numbers. Some have different currencies. And just imagine that you as a client don't have to worry what is your locale. You just have to send it, and there's a backend service that will format all your data and return it as strings, and you just display it. I don't know if anyone tried to introduce moment in front end. So it's around what, 300 kilobytes? Something like that, 300 to 400 kilobytes every time. So just imagine that you can lose that and leave it in backend where it belongs. Okay, a bit about caching. We're going to be using a data loader library, which was also created by Facebook, actually by a guy who Eric mentioned a bit earlier, called Lee Byron. So it's basically an object that receives, as a minimum set of data, a caching function. So its signature is IDs, and then it returns an array of promises. So basically, it's an ID to promise, like a key value store, but where key is an ID and value is a promise. So you're basically caching the promise, the resolution of a promise, which you can then reuse afterwards. A bit about that. So it takes a couple of options when you want to create it. So one is the batch loading function that I showed a little bit earlier. And there are also a couple of other options. But the most interesting one is this cache key function. It's basically that you can define your own cache key function and your caching logic with it. So if you don't want to cache stuff with just IDs or stuff like that, you can define a function that you want to be used as a caching key, which is pretty powerful when you think about the way that you can cache data then. So it has this very simple and minimum API. So there's load many, clear, and clear all. So that's it. Very simple API for caching everything. So I'm going to do a demo. And just to show how easy it is to use GraphQL, I'm going to be using just one hand. OK, so this is graphical. If you remember, I showed you when we were creating the GraphQL server, there was a parameter that we were sending, and it's called graphical true. So when you introduce that, you have this for free. So first thing that I will advise you to do is start creating fragments. Fragments are nothing more than primitives that you will use to compose your data fetching. So here I defined a drop-down fragment on the drop-down type, and it consists of ID and value. So we have a lot of situations where we have to fetch drop-down data for selects that are including car makers, car models, built years, types, subtypes, and all that kind of stuff, but it's always in the same type. So we can define a drop-down type and a drop-down fragment and then reuse it for every select fetching data that we are using inside our application. So look, this here is 1, 2, 3, 4, 5, 6, 7, 8 different resources that I'm fetching. They are all API calls in the background. And if I had to use a standard RESTful API without any sort of aggregation layer, that would in return mean 8 different API calls. So if I do this, I can't do it with one hand. OK. Could be that internet is working a bit slower. OK, it's here. So we are fetching makes. As you can see here, the response matches the query that we are sending. So makes here. And we say that it's drop-down fragment, and we defined makes as a list of drop-down types on our schema, which in return returns this array of, you can see like Jaguar, Jeep, blah, 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 everything like that. So one thing else that we can do, we can assign variables while we're querying. So let's say for an instance that I need specially Chrysler models, BMW models, and Mercedes models. You can see here that my response matches the query that I sent in the first place. So here we have Chrysler models, BMW models, Mercedes models, and so on. And it goes on. So it's worth mentioning that this whole data was fetched in one get-go. So it was once to the server, once back. What happened from the aggregation layer to the RESTful API? Actually, we don't care. If you have your architecture set straight, your aggregation layers and your RESTful API will be inside a private network, so you can forget about network latency and stuff like that. So, okay. So these are more or less how queries look like. But what about mutations? I'm gonna do this. Okay, so mutation, unlike query, has to be prefixed with a keyword mutation in front of it. So as you can see here, I have defined a mutation as create booking, as I showed you a little bit earlier, and it consists of this data. And there's all sorts of data that we are sending to it, but it really doesn't matter what it is. So here you can see that as a response, I'm getting something that I named booking fragment, and that is something that my query is expecting to get back from the GraphQL server. So I'm gonna uncomment this here. Yeah. So I created a car lead fragment, a customer fragment, and a booking fragment, which is then a combination of two different fragments. So you can combine them, you can compose them, you can do whatever you want with them. And when I execute this, yeah, so you can see data, we have a create booking mutation, we have a car lead fragment here called car lead, and it has ID, branch ID, email hash. I can, with no problem, do this. And, okay, I have the same response. So, the powerful stuff. Let's say I don't need a hash. I don't need an email. I don't need a branch ID. For a car lead, I need only its ID. So I'm defining on client side what I need. So I'm not stuck with the payload that my API is giving me. I, as a client, I'm defining what I need. Like, I don't know if there was ever an easier way on client side to define queries. If there is, please let me know. I would really like to know. Okay, so let's move this. Comment it out. Okay. So to see how far it goes, I'm going to show you one thing. So here I'm fetching two cars. I called it car with equipment and car with seller. So just to know what's what. So as I said before, equipments here is an API call. So based upon the ID of the car, we can fetch equipment that it has, and you can see that this one has like airbags, anti-block system, and so on and so on and so on. And basically that's a nested resource. We are fetching with another API call, but for us on the client side, we really don't care what's going on in the back. We are getting the payload that we need. Car with seller here, I'm going to show you. So fetching a car is one API call, fetching a seller is another one, and fetching context for that seller is another one. So that might look like really a lot, and that's why we are going to use the data loader that I showed you before. So as you can see, now I'm dispatching this request. And you can see executing API calls, blah, blah, blah. So I defined my car loader as a data loader inside my GraphQL schema. What that in return means that when I execute this query again, there's no fetching cars because those requests are cached and available. So data loader has a pretty simple and naive implementation, so it's a JavaScript map and it will get fuller and fuller and fuller until it crashes everything. So if you're going to implement that, use caution and a bit of brains. Okay. And basically that's what I wanted to show. Okay. Okay. Future. So the hype is real-time data. Everybody wants real-time data. We have things like reactive backends and stuff like that. So the future of GraphQL lies in live data and optimization. So there's a working spec for a subscription keyword, which is basically another GraphQL query in which we can define something as a subscription to a resource. And when you say execute subscription, that when that resource changes, your client will get notified and updated, which is pretty powerful stuff. Batching is the option of batching multiple GraphQL queries in one query. So if you have on your client side multiple GraphQL queries that are executing, that you can merge them all in one and batch it together and go with one get-go again from client to server. Defer. I really like this one. You can define parts of your resources as non-critical. So you can define, let's say that for a car, we need its name, leading image, and description at once. But all the other images that we are loading, we don't need them at all. We can defer them. So when our query gets executed, we will get the non-deferred resources, non-deferred fields types right away, and then afterwards we will get the things that we defined as deferred. Pretty good. Stream for long lists. Super keyword, if you ever dealt with long lists, you know it's a problem loading them and batching them, and batch loading those stuff can get really tedious and error prone, and it can become a mess. You can define a resource as a streamed resource, and then you will get batches of, let's say you have a list of 1 million records. You will get batches of, let's say, 100 by 100 list items until you reach 1 million. Live is also a way to attack the problem with real-time data. You will be able to define your resource as a live resource, and it will get live updated on your client just through GraphQL. So this is all in the makings. This is, I think, not open source still, but Facebook is very serious, and the last talks that I saw were all about live data in GraphQL. And a couple of useful resources. So if you're wondering what the hell has this to do with React, Apollo Stack is a great project that has emerged lately. Basically, it's a stack based upon GraphQL for data fetching, and you can use as a view library whatever you want, but they prefer you to use React, of course. Relay is an over-dimensioned GraphQL client. It offers quite a bit more, like really easy paging support, caching, and client-side caching, and stuff like that. But it's quite hard to begin with it, and if you're going to use it for a small app, it really makes no sense. If you want something that is down-to-earth, bare-bones GraphQL client for a small or medium app, use Loka. Loka is stripped-down GraphQL client, which just allows you to dispatch GraphQL queries. LearnGraphQL.com is a super site on which they implemented their own version of sandboxed graphical. They have a learning schema and an interactive way for you to learn how to create GraphQL queries, mutations, and all of that. GraphQL.org is the official site. GraphQL Weekly is a great little newsletter that comes once a week and has 4 to 5 different news all related to GraphQL. And this is GraphQL Swappy parse app. So I don't know if you know what Swappy is. So it's a Star Wars RESTful API. So somebody went to trouble and mapped the whole Star Wars universe in a RESTful API. And then somebody even more geekier than that made a GraphQL schema about it, so you can query it all the time. And it's available on this link. I will put the slides up, so that's why I didn't put the talks of these YouTube links, because it made no sense. But one of them is a talk called Zero to GraphQL in 30 minutes. And I really advise you, if anyone wants to start with this, to take a look at that talk. A guy is explaining in 30 minutes how to start implementing GraphQL in 3 different environments. One is Node.js, one is Python, and one is something that I don't remember. Ruby? Yeah. Thank you. Okay, so I really advise you for you to watch the talk. And this would be dum-dum-dum-dum-dum-dum.